Now we're going to do a slightly different type, not a flat earther. It's a guy named Gareth. He does a channel called See the Pattern. And he tries to have alternate science facts or views. So let him talk for a second.
In 1905, Einstein developed his theory of special relativity. It was an explanation of how speed affects mass, time, and space. It included a way for the speed of light to define the relationship between energy and matter. In it, he defined that the speed of light was constant. What many people may not be aware of is that Einstein did not hold this view for long, and would start to develop a theory which would allow for a variable speed of light. Let's dive in and find out more. 2 years after publishing his paper on special relativity, he wrote the following in a paper on the relativity principle and the conclusions drawn from it. These equations too have the same form as the corresponding equations of the non-accelerated or gravitation-free space. However, c is here replaced by the value c open brackets 1 plus gamma xi over c squared close brackets is equal to c open brackets 1 plus phi over c squared close brackets. From this it follows that those light rays that do not propagate along the xi-axis are bent by the gravitational field. This shows his thinking towards a concept where the velocity of light is altered by the gravitational potential. In 1911 he wrote a paper on the influence of gravity on the propagation of light and said the following. If c0 denotes the velocity of light at the coordinate origin, then the velocity of light c at a point with a gravitational potential phi will be given by the relation c is equal to c0 in brackets 1 plus phi over c squared close bracket. The principle of the constancy of the velocity of light does not hold in this theory in the formulation in which it is normally used as the basis of ordinary theory of relativity. Some might claim that Einstein developed his theory of the variable speed of light and then abandoned it. But if we follow his writings, we find he keeps going on about this point. In 1912 he wrote, "On the other hand, I am of the view that the principle of the constancy of the velocity of light can be maintained only insofar as one restricts oneself to the spatio-temporal regions of constant gravitational potential." A little later, in 1913, he wrote, "I arrived at the results that the velocity of light is not to be regarded as independent of the gravitational potential. Thus, the principle of the constancy of the velocity of light is incompatible with the equivalence hypothesis." Then later in 1914, in the case where we drop the postulate of the constancy of the velocity of light, there exists a priori no privileged coordinate system. Then in 1915, the writer of these lines is of the opinion that the theory of relativity is still in need of generalization, in the sense that the principle of the constancy of the velocity of light is to be abandoned. Then in 1916, in the second place, our results show that, according to the general theory of relativity, the law of constancy of the velocity of light in vacuo, which constitutes one of the two fundamental assumptions in the special theory of relativity, and to which we have already frequently referred, cannot claim any unlimited validity. A curvature of rays of light can only take place when the velocity of propagation of light varies with position. And then in 1920, second, this consequence shows that the law of constancy of the speed of light no longer holds, according to the general theory of relativity in spaces that have gravitational fields. As a simple geometric consideration shows, the curvature of light rays occurs only in spaces where the speed of light is spatially variable. Einstein's ideas remained relatively unknown because of a series of coincidences. In 1919, Eddington's solar eclipse observations were seen as confirmation of Einstein's 1915 form of general relativity, where the curvature of space-time causes a bending of the light.
Here, Gareth is what you could call data mining, or what is also called cherry picking. He's going through all of Einstein's research or writings or letters and saying, "Oh, this one agrees with me. This one agrees with me. This one agrees with me," And it is a logical fallacy because they are only selecting little bits and pieces of data that agrees with them. Einstein could have had a different theory of how light bent around objects, but we have more experimental proof nowadays. Therefore, we go with the general theory of relativity. And from 1905 to 1915, that's what Einstein was doing. After 1915 to his death in 1955, he was trying to find the grand theory of everything, which never really worked out for him. But it doesn't matter what he was working on, it wasn't found to be correct. The thing that we found that works with the general theory of relativity is what is called gravitational lensing. Light bends around large masses and creates things like the Einstein cross. There's a chunk of dark matter between us and this host galaxy or quasar, and it bends around and makes these 4 other dots and what's called the Einstein cross. Also, during the James Webb Space Telescope, there are sections of the image from that telescope that looked like the galaxies look like they're being bent and flexed, and that's also part of another proof of the general theory of relativity. There's more and more evidence than this, but these are two good pieces of evidence.
In 1964, Erwin Shapiro wrote an article about the 4th test of general relativity and said the following: because, according to the general theory, the speed of light waves depends on the strength of the gravitational potential along its path, these time delays should thereby increase by almost 10 to the minus 4 seconds when the radar pulse passes near the Sun. Such a change, equivalent to 60 kilometers in distance, could now be measured over the required path length to within about 5 to 10% with presently obtained equipment. The first test of this was performed in 1966 when a radar beam was bounced off the surface of Venus and Mercury, and they were able to measure the round-trip delay. It is important to note that in Shapiro's paper, he specifically mentions that the speed of light waves depends on the strength of the gravitational potential along its path, and yet the Shapiro effect caused when Googled is given as a time delay caused by the space-time dilation, which increases the time it takes light to travel a given distance, changing the emphasis away from the speed of light and back onto the ability of time to flow at a different rate. But we will come back to this point in a bit. Peter Bergman.
And that is because we have a generally better idea of what's going on. It is dilation of space-time.
To measure the speed of light, we need to be able to measure distance and time. The unit of time is defined by an oscillating system or the frequency of an atomic transition, and the unit of space is defined in terms of the distance travelled by light in the unit of time. We therefore have a situation akin to saying that the speed of light is 1 light year per year. To appreciate this circular argument and the fallacy in thinking our measure of time is not directly connected to the speed of light, consider the atomic clock and how it is used to define a second. Modern cesium clocks form by releasing a gas of cesium atoms into a vacuum chamber. 6 infrared laser beams are directed at right angles to each other at the center of the chamber. These lasers are used to push and contain the cesium atoms into a ball. 2 vertical lasers are then used to push the atoms up into the microwave cavity chamber. Under gravity, the ball of atoms fall back down. Some of the atoms might have changed state. When they fall back down, another laser is pointed at the ball of atoms. All those atoms that did change state then emit a photon, which is counted by a detector. The process is repeated many times while the frequency in the chamber is changed. Once the resonant frequency of the cesium atom is achieved, and the maximum number of atoms are forced into higher energy states, the second can be defined as the duration of 9,192,631,770 periods of radiation corresponding to the transition between 2 hyperfine. The duration of 9,192,631,770 periods of radiation corresponding to the transition between 2 hyperfine levels of the ground state of the cesium-133 atom. The problem is that, in essence, we are counting light waves going by, and when you get to 9,192,631,770, you say that a second has elapsed. You then use the second along with the speed of light to define a meter. So the meter is defined as the length of the path travelled by light in a vacuum during a time interval of 1 over 299,792,458th of a second. This concept sets in concrete the idea that the speed of light is fixed, but allows for time variations. Let's just consider what this result might tell us if we take into consideration that a gravitational potential can slow down the speed of light. At a lower elevation we would measure the transition. Light goes slower, so that second would appear to last longer. At a higher altitude light travels faster, and therefore the second will appear to be shorter. By comparison, at a higher altitude the photon is able to travel quicker, meaning that it is able to reach its count quicker compared to at a lower altitude. Time has not magically changed, just the speed of light, allowing for a quicker completion of the count. Consider as well the definition of the second and the meter at lower elevation. When the light travels slower, the second would appear larger, but these two exactly cancel each other out, leaving the meter unchanged.
Well, this has been measured. There was a probe called Gravity Probe A that was launched in 1976.
This graphic was
and
to
somebody
describe
who probably
the
knows more about it.
past measurement
Dr.
of warping of time in the solar system. This was Gravity Probe A. You may have wondered what Gravity Probe A was. We keep talking about Gravity Probe B. Gravity Probe A in 1976, a set of atomic clocks were launched to a height of 10,000 kilometers above the Earth in a rocket. An identical set of atomic clocks down at the Kennedy Space Center was ticking away, and the ticking rates of the clocks in the rocket were telemetered back down to the surface of the Earth in order to compare the rate of flow of time at 10,000 kilometers height versus the rate of flow of time on the Earth. The prediction was that time should flow more slowly on the Earth by 4 parts in 10 billion. And the measurement verified that, and it verified it to 1 part in 10,000, a beautifully accurate measurement of a tiny effect, but an effect which is enormously large around black holes.
A magical fabric is being bent by gravity.
That's just an example of a personal incredulity. You can't understand how it works, so it's magic. But there was a test. It was called Gravity Probe B, which went up, and it had 4 gyroscopes on it. And if a rotating body is in this space-time, it will make anything near it precess, like the Earth wobbles. So it went up, and there was a precession and what they call frame dragging. But Gareth does this a lot. I've gone through a lot of his videos. He cherry picks stuff, and he doesn't show any research that actually proves contrary to his findings or anything more recent than maybe like 1970s or 1980s. It's just, I don't want to believe it, so I'm not going to include it. But that's it now. Oh yeah, I hope Kip Thorne finds this stuff out. But, well, kind of like, this is silly. You're using my research to prove some silly point. But I hope everybody has a good day, and have a good day. I hope you enjoyed this.